Critical angle and total internal reflection. The critical angle and total internal reflection occurs due to the refraction of light. As we have said that whenever the light is traveling from the denser medium to the less denser medium, or to the denser medium, from denser medium to the less denser medium, undergo bending occurs, bending of light occurs. This bending of light at the boundary, this is known as a refraction of light. So the critical angle, this is a unique angle of incidence for which the angle of refraction is equal to 90 degrees. As you can see in the diagram here, whenever the angle of incidence increases until the angle of refraction is equal to 90 degrees, this angle is known as a critical angle. So suppose this is the plane surface, and the normal line, this is the imaginary line, which makes the 90 degree with the plane surface. So whenever the incident ray increases the angle of refraction also increases. The angle of refraction increases until the reflected ray lies parallel to the surface. Whenever the reflected ray lies parallel to the surface, in this moment, it makes the angle to be 90 degrees. The angle formed between the normal and the plane surface is equal to the 90 degree, or the refracted ray is equal to 90 degree. So at this moment, that angle of incidence is known as a critical angle. So in this case, C is the critical angle, while R is the angle of refraction. Total internal reflection. The total internal reflection, this is a physical phenomenon in which all light rays traveling in optical denser medium is reflected back to its original medium after striking the boundary of the optical placed denser medium. So suppose this is the ray of light traveling from water to air. This is the boundary between the air and the water. So at the boundary, the reflection occurs. Whenever the angle of incidence whenever the angle of incidence increases, the critical angle, the reflected ray also increases beyond the 90 degree. If it is increases beyond the 90 degree, this the ray of light appears to occur in the original medium. So at this moment, a ray of light says to undergo the total internal reflection. It goes and this way, then it strikes back, reflected back to its original medium, the total internal reflection. So there is a condition for the total internal reflection to occur. The first condition, a light must travel from the denser medium to the less denser medium, and not from less denser medium to the denser medium. As you can see from the diagram, the light must travel from the denser medium to the less denser medium for the total internal reflection to occur. The second one, the critical angle must be less than the angle of incidence, or the angle of incidence must be greater than the critical angle for the total internal reflection to occur. When you include the angle of incidence, also the angle of reflection increases beyond the 90 degree. Let us see the relationship between the critical angle and the refractive index. So suppose our medium is water now. Water. So the refractive index from air to water, that is the refractive index of water, is equal to sine I over sine R. So whenever we reverse the light ray, the refractive index will be from water to air. The refractive index from water to air will be the reciprocal of the refractive index from air to water. So in this case, it could be sine R to sine I. But when the when the angle of incidence is equal to the critical angle, the refracted angle could be equal to 90 degrees. So at this moment, the refractive index from water to air could be equal to sine 90 divided by sine C. But sine 90 is equal to 1. So 1 over sine C could be the refractive index of from water to air. This formula is true for all material medium. Here we're taking water as just a sample to represent others. Let us see the example here. What must be the angle, for instance, for a total internal reflection to occur when a ray travels from glass to water? The refractive index of glass is equal to 1.52 and the refractive index of water is equal to 1.33. So we're looking for the angle of incidence for the total internal reflection to occur. But we are given the two refractive indices. As you know that when the angle of incidence is equal to critical angle, the angle of refraction is equal to 90 degrees. Refractive index of the glass we have also the refractive index of water we have. Angle of incidence, we are looking for that the angle of incidence at this moment is equal to the critical angle. So we are looking for the critical angle. On treating this formula and making I as a subject, I now is equal to C at this moment when R is equal to 90 degrees. So on treating the formula, we shall have 61.04. This is the angle of incidence, which is equal to the critical angle. Angle of incidence, which is equal to critical angle. So since this is the angle of incidence, which is equal to the critical angle, so for the total internal reflection to occur, the angle of incidence must increase this 61.04 degree. It could be the answer. Thank you for watching. Welcome again. Don't forget to subscribe, share, and comment. Thank you.